Alright, going over the chapter 6 quiz. So this first standard is 6a, special triangles and Pythagorean triples. There's two things that are very important to know about these standards right here. But first, let me name this the key. Okay, the two things that we need to know are 30 60 90s and 45 45 90s. Those are called the special right triangles. So anytime we refer to these triangles, we need to know what the sides across from them are. And I'm going to label them here 1 root 3, 2, and then finally 1 1 root 2. These are the sides that we can use for reference for these special triangles. On top of that, the second thing we need to know is some of the Pythagorean triples. So Pythagorean triples, of course, are going to be where a squared plus b squared equals c squared. So there's some that we already know work. There's an awesome video I can show you, but for now I just have to just write them down. But construction workers, they use this all the time. There's the 3 4 5 Pythagorean triple. There's 5 12 13, but mainly they use the 3 4 5. In our class we mainly use these two, but there are a few others that we kind of need to have memorized, or just look at the board and it's there. 7 4 25, 8 15 17, and then 9 24 25. These are some of the first Pythagorean triples that satisfy the Pythagorean theorem. So, I mean, we might as well start off with number 1D. Number 1D is giving us 8 squared plus 15 squared equals x squared, since it's a right triangle. So 8 squared plus 15 squared equals x squared. But here's the thing. This right here is already a Pythagorean triple. 8, 15, 17. So even though we might want to try to solve this and get our answer by square rooting both sides and getting 17, we know that already, that it's 17 by the Pythagorean triples. So just to write this down, the answer is going to be 17 because it's a 8, 15, 17 Pythagorean triple. We can just kind of write that there. Pythagorean triple. Also written right there. Okay, number 1A, B, and C. Let's apply these properties of 30, 60, 90s, 45, 45, 90s to these ones, since these are special. Solving for x and solving for y. So the method that I showed in class is to label. Across from the 30 should be a 1. I'll write that nice and tiny. Across from the 60-degree angle, which we know is this one, should be a root 3. And the hypotenuse across from the 90 should be a 2. Now we just have to use scale factor to determine what the answers could be. So if we look at this matching pair of sides, the scale factor is 12 over 1, which we know is 12. So I'm going to go ahead and circle that as a scale factor. So step 1, label correctly. Step 2, scale factor. And step 3, multiply. Once we know the scale factor, we just got to multiply these numbers by what the scale factor is. So let's do that. Twelve times 2 gives us 24. And 12 times root 3 gives us 12 root 3. Okay, let's do letter B. Letter B is also a 30, 60, 90 right triangle, so we need to label the sides with these sides right here. So across from 30, which I know is this, since that's 60, Across from 30 should be a 1. Across from 60 should be a root 3. I'll write it underneath it. And across from the 90-degree angle should be a 2, or the hypotenuse. Also labeled from least to greatest, if you forgot. So least to greatest, these numbers are labeled in least to greatest. So now our step 1 is done. Step 2 is to determine the scale factor. We determined that by dividing the two, the match of corresponding sides. So we're going to get 12 divided by root 3. Now 12 divided by root 3, I need to do something called rationalizing the denominator. You can look up a video on YouTube to see some examples if needed, but rationalizing the denominator is where you multiply the giant 1. You don't really need to show this, but it needs to be multiplied by whatever is in the denominator. So since I have a root 3 in the denominator, I need to multiply by root 3 over root 3. I can do this because this is a giant 1. What is root 3 divided by root 3? It's 1. So we're just going to get an equivalent form of 12 divided by root 3. This gives us 12 root 3 over 3. Let's simplify this now. 12 root 3 over 3. We can simplify 12 over 3. And that gives us 4 root 3. That's our scale factor. So I'm going to write that in red right now. Scale factor, 4 root 3. All right, now our next step is to apply the scale factor. Let's multiply the scale factor by the sides. So if you notice that we have a 2 for the y, that just means we need to multiply that by 2. So 4 root 3 times 2 gives us 8 root 3. And 4 root 3, 4 root 3 times 1, number that I labeled there, will be just 4 root 3. Now there are some patterns you can notice if you're listening. That's great. You can find this out. There are some patterns you can notice by whenever you square root or rationalize the denominator. It'll become whatever 12 divided by 3 is 4. And then it's root 3. So if I said, what's 16 divided by root 3? Well, I don't think I can do that because 3 doesn't go into 16. I need to do it a different way. But if I do, say, 18 divided by root 3, what's 18 divided by 3? 6. So in the end, after all the steps, you're going to get 6 root 3. It's just a little trick. So letter C. Letter C, step 1, let's label the sides according to the 45, 45, 90. So we need to label this 1, 1, root 2. Meaning I gotta divide this to get my scale factor. Same thing here. Scale factor is 8 divided by root 2. So let's rationalize the denominator. RTD, I suppose. So the trick here, there is 8 divided by 2 is 4. 4 root 2 should be the answer. But let's show our work. Multiply by the giant 1. Root 2 over root 2. I'll write this in green since it's getting a little bit messy here. Multiply by root 2 over root 2. What that gives us is 8 root 2 over 2. But what's half of 8? 8 over 2 is 4. So we're going to get our scale factor of 4 root 2. Scale factor. Use the trick. It can help out sometimes. So here's the wonderful part about using scale factor for the 45, 45, 90s. What do we actually need to multiply by? Right? We just need to multiply by 1. So if we multiply 4 root 2 by 1, 4 root 2 by 1 is just 4 root 2. So that gives us the answer. Okay, next up is problem number 2. Problem number 2. Angle theta is an acute angle in a right triangle. Okay, I see that. If sine theta is 5 over 13, Find the value of cos theta and tan theta. Well, I'm going to go ahead and label this. If I know that sine is opposite over hypotenuse, I know it's going to be 5 over 13. Now, yeah, some people can write the letter x here, but what kind of right triangle is this? We have all these special Pythagorean triples that we can use to solve this for the value of x. So yeah, could I do 5 squared plus x squared equals 13 squared and solve for it? I could, but I can recognize that this is a 5, 12, 13 Pythagorean triple. Okay, so that means that this side right here has to be 12. 5, 12, 13. Okay? So now that I know what this triangle looks like, I can find out what cos is. Cos is adjacent over hypotenuse. So adjacent hypotenuse, that'd be 12 over 13. Tangent is opposite over adjacent, so that would be opposite of theta over the adjacent side, which is 5 over 12. So 5 opposite, 12 adjacent. The answer would be 5 over 12. So first answer, 12 over 13, 5 over 12. And notice that it's different than sine, because that's a different trigonometric ratio, or trig ratio. Okay, let's go ahead and do the back side. Let's flip to the back side and solve these questions here. This one I might need to use a calculator a lot more, so I'll have this handy just in case I need it. Number 1, I'm going to multiply the whole numbers together first. It's just a method. There's many methods to use, but this is a method that I use a lot. So 2 times 3 is 6. And another method I can use is just combine the 6 and the 18 together under one square root symbol. So if you noticed, I just did the 6 and the 18. I put them under one square root sign since I can combine them. So let's just see what that 6 times 18. It's 108. So we get 6 root 108. Is that fully simplified? Ask yourself that question. Is it fully simplified? I'm going to write down all of the perfect squares. It's possible to write down all of them. I don't think so, but I'm going to write down the first numbers that could go into 108 that are perfect squares. So 49, 64, 8 times 8, 9 times 9, 10 times 10, and 11 times 11. I think that we can stop there. Now, we need to ask ourselves, look at the square root of 108. If these are called perfect squares, then we can take the square root of this and hopefully get a good number. Well, notice 108 is between 100 and 121, meaning it's going to be a decimal. So if I do the square root, which I see this button right here, square root of 108, it's going to be a decimal. It's got to be. We don't want any decimals. This says no decimal answers. So what number goes into 108? Let's divide them by these numbers to see if any of these go in. So I know 100 doesn't go in. 81's too big. 64, does it go in? No. 108 divided by 49? Nope. 108 divided by 36? There we go. 36 times 3 is 108. We can confirm 36 times 3 is 108. So what I'm going to write is, I'll keep the 6 there, but what I'm going to rewrite the 108 is I'm going to write that as 36 times 3. What this allows me to do is it gives me the perfect chance to square root this. So I'm going to do a separation method. I'm going to separate these two right here just to show it. You can skip this step if you really need to because it's an obvious step. But you can separate them. You can take the square roots, take them out anytime you want. But 6 stays there. Square root of 36, that's 6. And root 3 stays there. So finally, what's 6 times 6? 36. 36 root 3. Answer. Okay, number 2. We're going to rationalize the denominator since we cannot have any radicals. So we need to multiply by root 8 over root 8. And I'm going to put a little note here. There is a trick. I do want to show the trick at the end. It's kind of tricky. I just figured it out how. But there is a trick that I want to show you. So we're going to get 4 root 8 over 8 since these two multiply to 8. And this multiplies to 4 root 8. Okay, let's simplify that. So 4 over 8, that's half. So root 8 over 2, that's a half. 1 over 2. But 8 is a perfect square, so I need to rewrite the 8 as 4 times 2. It's a perfect square right there. Inside of the square root symbol. So that gives me the square root of 4 is 2. 2 root 2 over 2. Square root of 4 is 2. Root 2 stays in the root. Okay, and now I need to cancel out the is root 16. Kind of tricky, but 16 divided by root 8. Yeah, there's a method you can combine them under one square root sign. 16 divided by 8 is 2. So root 2, this is another way to get your answer very quickly. It's creative, but it's harder to make sense of. Like, why would you do that? Okay, next up, number 3. There's 2 rules for imaginary numbers. I squared is negative 1 because I is the square root of negative 1. There's 2 rules we need to remember for imaginary numbers. They'll be written on the board during the test, though. So for number 3, so many of you got this right. It was fantastic to see. We had negative 3 minus 4 is negative 7. And just treat the imaginary numbers like a variable, like 5 apples. So if I have negative 5 apples plus an apple, I'm going to get negative 5 plus 1 is negative 4 apples. You cannot combine these two numbers. It's called a complex number for a reason, because it has a real number plus another number, any random real number, multiplied by an imaginary number, which is the square root of negative 1. Complex. Okay, next up is we're going to use a method called area model for this one, since I notice it's 2 terms by 2 terms. So 2 minus I multiplied by 3 minus 6I. I'll zoom in for this one. 3 times 2, let's just multiply this. 3 times 2 is 6. Negative 6I times 2 is negative 12I. 3 times negative I is negative 3I. And finally, for this last one, I want to do the work on the side for this because it's going to be I times I. I know I times I is I squared. So I have to be very careful about this one. So I'm going to do the work on the side. Negative 6I multiplied by negative I. Let's just multiply what it is. So we get negative 6 times negative 1 is positive 6. I times I is I squared. So far we did negative negative is positive. I squared is I times I, so I squared. Now what is I squared defined as? I squared is the square of the square root of negative 1, so it's going to be negative 1. So this is going to be 6 times negative 1, which is negative 6. I'm going to write that right there because that's the two numbers that we just multiplied. Right there. Okay, what does this give us? So 6 minus 6, those are like terms. That crosses off. And we get negative 12i minus 3i. That's going to be negative 15i when we combine those two right there. That's my answer. Okay. Last 4 problems. Number 5. I'm going to use a very careful method with number 5, just because imaginary numbers can be very tricky sometimes. You might be tempted to multiply negative negative, turn it positive, but you can't. Because what is I times I? An imaginary number times another imaginary number, right? An imaginary number times another imaginary number is going to be negative 1, so we have to be very careful with the negatives. Let's rewrite it. I'm going to say 14 times negative 1. And I'm going to say 7 times negative 1. Now, just like we did here, we separate them. We can separate these as well. So this step you can even skip if you wanted to. It's going to give us square root of 14, square root of negative 1, multiplied by square root of 7, square root of negative 1. Okay, next step is going to give me root 14i, because that's I, defined as I, multiplied by root 7i, because that's also defined as I, as mentioned over here. Okay, what that gives me is we can combine 14 times 7 under 1 square root. Just to show all the work. We can go absolutely crazy, show every single step, but it's going to be I times I is I squared. What's I squared? Right? I squared is defined as negative 1. So this is going to be 14 times 7. Let's just multiply that together. 98 multiplied by negative 1. Not inside the square root, but outside the square root. So we know this has to be a negative answer. Okay, we need to simplify 98. What number goes into 98? The biggest number that goes into 98? 49, I'm pretty sure goes in. Let's check. 98 divided by 49. Dividing by the perfect squares. 2. Okay. This gives me negative. I'll put it in the front. I'll say this is 98 is 49 times 2. Just separate them now if you want to. So we get negative 7 root 2. Since the square root of 49 is 7. And that's your final answer. Next up, number 6. Rewrite in radical form, then simplify. This is an 8. So let's rewrite in radical form, then simplify. Okay, this is going to be a cube root since it's a third power. Or sorry, 1/3 power. And this is going to be 8 to the 2. You can put the 2 inside or outside, right? So right now I need to simplify this, so I'm going to take the cube root of 8 since I know that. Some people have asked me, where's the cube root button? there's a square root button right there. But where's the cube root? So I go to math, and I have all my options there. Cube root, fourth root, fifth root, eighth root. Let's just do this one right there. Press clear again. I'll try it again. Math, option 5. And here I can change it. Some calculators have different functions, so it's a lot easier to just be like, oh, fifth root, let me do 5. Math, let's try it again. 5, math, option 5. This is going to be a fifth root of 512, and it gives you the answer. But in this case, we're doing a cube root, so might as well just use option 4 here, since it's a cube root. Cube root of 8. Cube root of 8 is 2. So we get 2, and 2 squared is 4. Now there's another way to do this. You could have done, starting from here, you could have done 8 squared. So if you did 8 squared, you could have got cube root of 64. 8 squared is 64. And what's the cube root of 64? Let's see. Cube root of 64. It also gives you the answer of 4. So either way, this is definitely going to be a confirmed answer. Okay, next one, number 7. Is this a square root? Everybody knows it's a square root, so there's going to be a secret 2 over there, since it's a square root. If it was a cube root, of course it would be a 3. If it's a fourth root, it's a 4. But this one's going to be a square root, so there has to be a number there, giving us the opportunity to write this as 5 over 2. X to the 5/2 power. Finally, number 8 is going to be laws of exponents. Let's see how we can capitalize on this. All right, for sake of organization, I'm going to go ahead and color code this as best as I can. So 5 over 15, I can simplify that to 1/3. So I know I'm going to just change this to a 3 and that to a 1, which isn't necessary, but the 3, I know that's going to be a 3. So right now, I do also have a negative power. I need to bring that down with this one. The y can stay there, but there is a negative power for y. It needs to go up. And finally, z. These are both positive, so we can leave them there if we'd like to. I'll leave them there just for now. Okay, what this gives us is, let's put the fraction symbol. Okay, what this gives us is we know that there's going to be a 15 in on the bottom. Actually, it's 5 over 15, which is 5 over 15 is 1/3. So I know there's a 3 there. The x to the negative 3rd power, that goes down as x to the 3rd on the denominator, while x to the 5th is still there. Y is up here. And to bring the y to the negative 1st power, we need to bring that up. That's going to be another y to the 1st power. And finally, we have z cubed over z squared. Let's simplify this. It gives us y squared z cubed. Oh, but what's z cubed over z squared, right? We know that there's a subtraction rule, so we can do z cubed minus z squared, or 3 minus 2. So z over z gives us just z. There's only one z on the top, one z. And in the denominator, still a 3 from there. There's going to be x to the 3rd times x to the 5th, which is x to the 8th. And I'm done. That's my answer. Okay, another way to do this problem is to subtract exponents. So if I said if I said 5 over 15, in green it would be x to the negative 3 minus 5. For the y's, it would be y to the first minus y to the negative 1 power. For the z's, it would be 3 minus 2, which you see right there, 3 minus 2. Giving me 1/3. This will be negative 8, meaning it's going to be in the denominator as positive. This will be 2. 1 minus negative 1 is 2, so y squared in the numerator. Y squared in the numerator. And finally, the z. 3 minus 2 is just 1, so we have a z in the top, so in the numerator. So that gives us two methods to get the same answer. As you can see, we get the same exact answer there. Use the method that's best for you. I hope this video was serving a purpose for you today. Have a great rest of your day, and see you again soon.